Okay? What is it? Is it the same problem?
No. I want to tell you what I did.
Yeah, can I quickly finish this? I need you to attempt this. Please listen. Show that this summation equals this. It's quite different from, actually I wish we could maybe practice more and supervise practice, I mean, so that I can always, tell you this is what you should do and things like that, but hopefully maybe the first 5-10 minutes of tomorrow you can show me what you did here, then I can do the correction, and I will encourage you to do similar question that has to do with summation of products. Long terms, basically. Okay, so quickly, this is what you should achieve. You should know that when n is 1, it means you are adding one term on the left, because this is about summation. Summation of r equals 1 to n must give you this. So when r is 1, you are adding from r equals 1 to 1, basically, which means you are considering the first term. And it must be equal to n equals to 1 here. So your left-hand side is talking about the number of terms to be added. Your right-hand side is about the value of n to substitute. So it's slightly different from some of this. So if I want to check P1, P1 means I consider the first term and I substitute 1 and I see if then left and right are equal. This time around I will consider left side and right side. Okay? For my P1, I will say left-hand side equals 1 times 1 factorial, which is 1. Right-hand side equals 1 plus 1 factorial minus 1, I will get 1 also. Then I will say because left is equal to right, P1 is true. If I want to consider P2, for my left-hand side, I will consider the first two terms. Remember, your left-hand side is about summation from 1 to n. So when n is 2, you are adding from 1 to 2. That's going to be 1 factorial, 2 factorial. Okay? And what is that? This is 1, this is going to be 4. Isn't that 5? Okay? Then your right-hand side, on the other hand, your right-hand side is just to substitute when n is 2. And that is 2 plus 1 factorial minus 1. 3 factorial is 6, minus 1 is, so they are equal also. If you want to consider P3, I'm not saying you should. When n is 3, you will have these 3 terms on the left, and on the right, you just substitute when n is equal to 3. Does that make sense? Because of the summation, you are adding from 1 to that position. So if you have chosen the position to be 1, you add from 1 to 1, which means it's just 1. If you have chosen the position to be 2, you add from 1 to 2. And on the right, you compare with when n is just 2. If you have chosen the position to be 3, you add from 1 to 3. On the right, you consider when the position, of course, is just 3. Does it make sense now? And inductive hypothesis is easy, same way. It's just going to be this, but this time around, you are dealing with k. And this also remains k. I'm only trying to explain these first basic steps. So when you are dealing with summation or product, you have to consider that the left is how many terms you consider, either to add or to multiply. And the right is just the value of n to substitute. That's the difference between this kind of induction problem and the ones you have done so far. Any questions? I'll see you tomorrow.